In this video, we'll extend our problem solving to include two triangles. We're going to take a look at two different kinds of questions today, one which includes a system of equations and one which doesn't. In this video, we'll actually be practicing in class over the course of the next couple of days. Now let's go ahead and get started. In number one, it says a firefighter on the ground sees a fire break through a window. The angle of elevation up to the windowsill is 32 degrees, whereas the angle of elevation up to the top of the building is 40 degrees. The firefighter stands 72 feet away from the building, and they want to know what the distance is from the roof to the windowsill. They've drawn us a nice little picture, which is super helpful here. But as far as what it is that we're trying to find this distance from the roof down to the windowsill. So as far as where that is in our picture, we're looking to find the length of that little line segment right there. I'm going to call that D. And if I go and I look at the picture, we really have two right triangles that are living in this picture that we can use. We've got the green triangle, which is a right triangle, and we've got the blue triangle, which is a right triangle. And as we've done so many times before in this course, whenever we have two triangles where one sits on top of the other, we found separating the two triangles a very helpful strategy. That's going to continue to hold true here as well. So what I'm going to do is I'm going to draw the blue triangle separately from the green triangle. So my blue triangle, my right angle is down at the bottom. This horizontal distance is 72 feet. The angle of elevation is 32 degrees. And likewise, when I draw the green triangle separately, he's a little bit bigger. His angle of elevation now is 40 degrees, but he has that same horizontal distance of that same 72 feet. I can use trig to find the height of the blue triangle, which I'm going to call x. I can also use trig to find the height of the green triangle, which I'm going to call y. And notice how I very clearly define those variables in my picture. Both of those are labeled very clearly. When I go to find x, it's very clear that x represents the vertical height of the blue triangle. And when I go to solve for y, it's very clear that y represents the vertical height of the green triangle. And now if I go to the picture, there's my y, there's my x. You can see that D, what it is that I'm trying to solve for in this problem, is going to be the difference between x and y. So my first order of business here is going to be to go and to solve for x and y. So if I'm thinking about my trig functions, I've got opposite and adjacent in the blue triangle, opposite and adjacent in the green triangle. The trig ratio we know that deals with opposite and adjacent is the tangent ratio. So I'm going to go ahead and get busy doing some work involving the tangent ratio. So in the blue triangle, I've got tan of the 32-degree angle is equal to the opposite side, x, over the adjacent side, 72. So this is a nice easy one to cross multiply. When I cross multiply, I end up with x is equal to 72 times the tangent of 32 degrees. I'm going to stop right here and I'm going to go do some work on the green triangle now. I've got a value for my x. It's kind of an abstract value because I'm leaving it in terms of tangent so that I'll have an exact value. But I've really done as much work with that blue triangle now as I possibly can. In the green triangle, my angle is 40 degrees, so I've got tangent of 40 is equal to the leg opposite, which in this triangle is y, over the leg that's adjacent, 72. And again, I'm going to put that tangent of 40 over 1 so that I can go ahead and cross multiply. So y now is equal to 72 times the tangent of 40 degrees, or the tangent of 40. You can or don't have to put the degree sign on. It doesn't matter. It's right either way. I'm going to take my degree sign off that first one just so that both of them are consistent and the same. And now if I go to look at my picture, that distance from the windowsill down up to the roof is going to be the difference between y, the height of my green triangle, and x, the height of my blue triangle. So when I go to fill this in, D is equal to 72 times the tangent of 40 degrees. Subtract 72 times the tangent of 32 degrees. And now that, and only now that I'm in the very last step of my problem, I'm going to go plug all this into my calculator. So I'm going to check to make sure my settings are in degrees, which they are. I've got 72 times the tangent of 40. From that, I want to subtract 72 times the tangent of 32. So now I have to go back to the problem and I have to see exactly what it is they want me to round to. And in looking at the problem, they're wanting me or asking me to round to the nearest tenth of a foot. So to the nearest tenth of a foot, that distance from the windowsill up to the roof, and I'm going to use my squiggly parenthesis or equal sign here, so about 15.4, and I want to include my units of measure, feet. So when you come back to class the next time, we're going to be looking at lots of problems that are similar to this one in that they involve the use of two triangles where you will have to find the lengths of two of the sides in order then to either add them together or subtract them, as in this case, so that you can find a third measurement. The problem that we're going to look at now is a really good one, and it's a nice integration of algebra from last year together with the geometry that we've done thus far in this unit. And we'll actually look at problems like this, not when you come back to class tomorrow, but when you come back to class the day after tomorrow. So this is going to involve the use of some systems. So in this problem, it says Jack and Jill stand 20 meters apart. And if you take a look in the picture, you'll note the distance between them. Jack sees the top of the building at 30 degrees, whereas Jill sees the top of the building at 40 degrees. What is the height of the building? Well, like the very first question that we looked at, this one too consists of two triangles where one sits entirely on top of the other. So my strategy is going to be to separate those two triangles from one another. And I'm going to do that right in the very beginning. So I've got that nice purple triangle. I've got the blue triangle where they're overlapping. I'm going to go ahead and pull those apart from one another. So in my purple triangle, I've got h, the height of the tower. I've got that 30-degree angle of elevation, and the whole horizontal piece of my purple triangle is x plus 20. My blue triangle, on the other hand, I still have that same vertical distance of h, but this time my horizontal distance is x and my angle of elevation 40 degrees. So very similarly to the first problem, when I look at this question, we're dealing with opposite sides and adjacent sides in both triangles. So this one too is going to be a tangent problem. And I'm going to go ahead and get busy same way I did on the first two, or the first one. So in that purple triangle, I've got tangent of that 30-degree angle is equal to the leg opposite, which is h, over the leg adjacent, x plus 20. And notice the two variables in my equation right now, that's kind of my big hint that I'm probably going to need a system of equations in order to solve this one. So like I did in the first one, I'm going to go ahead and cross multiply. H now is going to be equal to the tangent of 30 degrees times the entire quantity, x plus 20. And again, like in the first one, I've kind of reached a standstill where I really can't go any further or do any more. So now I'm going to go take a look at what I've got going on in that second blue triangle. So when I set up my trig ratio in this triangle, tangent of 40 degrees now is equal to the leg that's opposite, h, over the leg that's adjacent, x. And again, I'm going to employ that strategy of cross multiplication. So h now is equal to x times the tangent of 40 degrees. Now this, folks, is where things really start to get fun. I've got h equal to one thing over here, but something different over here. So I'm going to do a little substitution, and I'm going to say that the value of x, or h in purple, which is equal to tangent of 30 degrees times the quantity x plus 20, is equal to the value of h that I have for the blue triangle, or in other words, x times tangent of 40. On the left-hand side, that's kind of crying out for me to go ahead and to distribute, so that's what I'm going to do. Tangent of 30 times x, or I might even make that x times tangent of 30, plus 20 times the tangent of 30 degrees, is equal to x times tangent of 40. And here's where, when I look at this problem, I'm now seeing x's on the left side and x's on the right side. I want to add or subtract until I get all of my x's. It's the only variable left in the problem, all of my x's on the same side of the equation. So I'm going to subtract x times tangent of 30 degrees from both sides of my equation. So when I subtract it away from the left, all I'm left with is 20 times the tangent of 30 degrees. And when I subtract it away from the right, I'm left with whatever was already there, the x times the tangent of 40, subtract x times tangent of 30. But again, my big idea is that now all of these x's are on the same side of the equation. That's important because now both terms on the right-hand side of my equation have a greatest common factor of x. So I'm going to go ahead and I'm going to factor that greatest common factor out. So on the left side, I've still got my 20 times my tangent of 30 degrees. But on my right side, when I take out the x or factor out the x from both terms, I've got that x on the outside of my parentheses. And on the inside of my parentheses, I've got tangent of 40, subtract tangent of 30. And now, in order to isolate x, I've got to undo multiplying by that term inside the parentheses. So to undo multiplying by that term, I'm now going to divide both sides of my equation by that term. And notice I said I'm going to do that on both sides. So at long last, I've isolated the variable. I've isolated that x. X now is equal to the tangent of 40 degrees, subtract the tangent of 30 degrees. No, I lied. Let me go back here. X is on the right side of my equation. X is going to be equal to this term on the left side. 20 times the tangent of 30 in the numerator over tangent of 40 degrees minus tangent of 30 degrees in the denominator. Whew. Wow, that's some good work. At this point, I feel almost as though we've run a marathon and we should be done, but not really, because if I go back and I read what it is that we're trying to find, our mission is to find the height of the building. And the height of the building in the picture is h. Well, folks, we can find h by going back and substituting our value of x into either one of these two equations. So I can use this first one. I can also use the second one. I'm going to pick the second one because, as I hope you can see, it's going to be a little bit simpler to substitute into than the one that is in purple. But either one of those will get you to the right spot. So from up above, we said that the value of h was equal to x times the tangent of 40. But our x value is this fraction in purple, 20 times the tangent of 30 over tangent of 40, subtract tangent of 30, all of that is going to be times the tangent of 40 degrees. And now that I'm down here to this last and final step, now and only now do I go and grab my calculator. So I've got 20 times the tangent of 30. In the denominator, I've got tangent of 40 minus tangent of 30. And then I want to multiply that entire fraction times the tangent of 40 degrees. And I'm going to take a minute now to make sure that I've entered that into the calculator correctly, because there's a lot of room for error there. And once I'm satisfied that I've indeed entered that into the calculator correctly, then and only then will I hit enter. And if I'm not mistaken, in this problem it tells me they want to find the height of the building. Oh, they don't ask us to round or tell us what to round to. So I'm going to say to the nearest meter, this building is about 37 meters tall. And I'm going to use those squiggly equal sign to indicate that I've rounded my answer. All right, so at this point, I've now gone longer than I really like to do. So why don't we save the key ideas for when you come back to class? And why don't you save that check your understanding question on the next page for when you come back to class also. We'll take a look at that together the next time you come back to class. And remember, if you're feeling a little bit overwhelmed right now, remember that this lesson is going to be practiced over 2 days during the course of your class. All right, as always, thanks for listening, and we'll see you the next time you come back to class.